Gambarova, and I will be presenting my assignment on last week. And this is our last assignment, and the name of the assignment is Exploratory Data Analysis in Python. I'll go ahead and share my screen so you can see my Jupyter Notebook. So, EDA. First task was about referring to assigned readings. So from my reading, I understood that EDA is a crucial process of conducting first investigation on data, or in order to find patterns and identify anomalies, test hypotheses, and verify assumptions with the use of summary statistics, graphical representation, and it's all known as EDA. EDA's primary goal is to assess the data before drawing conclusions, and it assists you in finding errors and better comprehending data patterns, identifying outliers, and any relationship between variables. So, task number 2, to download the data. And I am using the used car prices in India dataset I downloaded from Kaggle, and my dataset has following fields. It has both categorical and numerical fields. And when we will doing summary statistics, I will go I will give more details about the data set. So here first in step 3, we are starting performing summary statistics or descriptive statistics. We are downloading our libraries, and here we go. We have shape of our data set. It is 6,000 rows and 14 columns. As you can see, our fields are a combination of numerical, and here it's string, but I will convert it to categorical data. So yeah, it is what we have. Let's look at our first 5 rows. We have name of the car, location, the city in India, year of the car, kilometers driven, fuel type, transmission, owner type, mileage, engine, power, seats, new price, and the price, current price. Already I see notes. So, and the next step would be cleaning the data. So first we are looking for duplicated rows, and we can see that there are no duplicates. And then we are looking at missing values. So as you can see, the column new price has 5,000 missing values out of 6,000. And engine has 36, seats 42, and most of the fields don't have any nulls, which is really good. And here it's just in percentage interpretation, and same for nulls. So as I said, new price has the most missing values, and seats and engine, power engine has relatively less, like a small amount of nulls. Here we are looking at the summary of the fields, and let's look how skewed is our fields, our data in the fields. And we will understand by comparing mean to median. And here we can see, so median and mean are different for year. So if median is smaller, then it means our data is skewed to the left. For kilometers, it is 58 and 53. So we have skewed data set to the right, and for seats, it's almost the same. And for the price, 5 and 9. Oh, there is a huge difference, which means we have outliers and data distribution is skewed to the right. And in the next code, you will see that I have an error, but I deliberately included the error to show that, to highlight the necessity of the data cleaning. So I tried to convert data types to category type, but my error was that there was like float wasn't, they couldn't convert string. So as you can see, we have here kilometer per kg, which kilograms, I assume. So I was looking for this value in the data set, and as you can see, we have a lot. And then I am removing these values from this string. And also I have more errors and that were indicating that we have PHP in power and CC extension in engine. So I didn't include that errors, but I removed them. And then I was able to change the data type, as you can see. Next, we have summary statistics. Again, here we are, it is the same as previous. We were looking at the distribution of the data, and what we are doing next. We are trying to understand the distribution via graphical representation. And here, as you can see, our year is skewed to the left. Mileage, we can say it's normally distributed, but it has some outliers. Engine, it is skewed to the right, same for the power and same for the price. So the next, I have another descriptive statistics visuals here. Most of the cars are available in Mumbai, and in Ahmedabad, the least amount of cars. Fuel type, most of the cars, more than half of the cars are diesel fuel type, and second is petrol, and then transmission. Interestingly, most of the cars have manual transmission, while I would think that mostly they are automatic, but not in India. And ownership, like almost 82% of the owners are first owners. And step 4. Actually, it's not step 4, it is task 4. I apologize, but here we are identifying potential research questions, and here I have some examples. Like, for example, we could look at the price distribution, and research question would be, what is the distribution of used cars in the data set? Or mileage comparison with price. And hypothesis would be cars with lower mileage may have higher prices, for example. In our next steps, we are going to look at try to address the questions 4 and 5. So 4, transmission type and pricing. Question, are automatic transmission cars more expensive than manual transmission cars? And 5 is gonna be question regarding engine relationship between engine and price. Okay. The next thing we are doing, we are looking at the correlation of the numeric variables, and you can see engine has the strong positive correlation with power, and engine it's 0.87. Car price has positive correlation with engine. We look at price and engine at 0.66, and with the power it has 0.74. Power and price, I would say, is like highest correlation of the price. And mileage has negative correlation with engine and power. And price has very small correlation with year, and kilometer driven doesn't impact zero price. Interesting finding. On the next steps, I am checking for normality, linearity, and homogeneity assumptions, because I am going to perform I'm going to answer the question, are automatic transmission cars are more expensive than manual transmission cars? And I'm going to compare the means of the prices between automatic and manual cars. So I want to perform t-test. But here we can see p-value is less, so for Shapiro, we'll test p-value is less, which means it's not normal distributed. And here we can see that's skewed. The second assumption, so excuse me, here we have my explanation. And then second assumption is homodesticity. And here we are using Levene's test, and again it's 0, which means we are rejecting the null hypothesis, which means homogeneity assumption is not met. In this case, we can't use a t-test, and we consider using non-parametric test because assumptions are not met, and we will be using Mann-Whitney U test. And here, result of the Mann-Whitney U test is p is 0.0, and it means we are rejecting the null hypothesis, which means there is a significant difference in prices between automatic and transmission cars. I'm exceeding my time limit, so I will leave regression model visuals here. As you can see, we have a little bit linear relationship between price and power. This one is actually not price and price, it's price and future price, I guess. But the highest correlation, I would say, we can see from this price and power. And we are performing OLC test and all the assumptions. And as a conclusion, we can't use a linear regression model because our assumptions are not met. Thank you. Bye.